So we have one subject left before we finish the last lesson, which is the lesson 14. And this is named pipes. So we have seen pipes which take a command on the left and another command on the right. So the output from the command on the left is passed as input to the command to the right. And this is done by the shell through the pipe. Now, this is like an anonymous pipe without name, no-name pipe, but it is. We can also create named pipes, and with named pipes, we can do something like this. For example, command 1, and then send it to the named pipe. It behaves like a file. So we redirect the output of the command to the pipe as if redirecting to a file. And then we can write another command that is reading from this file. So this command is getting the input from this pipe. So this named pipe is like a file, but it is first in, first out structure, or it is a buffer first in, first out, which means that the lines that go in first go out first to the other process. So let's create a pipe. We use the command make FIFO. This FIFO is first in, first out. And then the name of the pipe, for example, pipe 1. And let's look at the attributes of this file. We see that it has a P as the first letter. So a normal file usually has just a minus as the number, as the first letter of the attributes. A directory has a D, and there is an S sometimes for a sticky bit. But a pipe is a special kind of file, and it has a P here. And also it is displayed with a different color by the shell. So now how does it work? Let's type a command that generates some output. For example, LSL, and then we can send the output to pipe 1. And then we append this ampersand so that this command is executed on the background. So it is still running. So this command is still running in the background. And it is trying to send some output to this file, but no other process is reading the output. Now we will write a command that is getting the output from this pipe. For example, it can be the command cut. And now the command cut is getting the output that is coming through this pipe from this command. So this command is sending the output to this pipe, and this command cut is output from the pipe. It is similar to writing LSL and then pipe cut. It does the same thing, but this is more flexible in some situations. So in some cases, it is better to use a named pipe instead of a pipe. So let's see a case like this when it is different. Using a named pipe, it is better than using a normal pipe. For example, if we say echo, or let me clear the screen first. Echo something, and then we use the command read, trying to read some input. the input that is coming through the pipe. And now we do echo reply. The answer should normally be in this variable reply, but it is empty. Why? Because when this pipe is used, the shell is creating, Bash is creating a subshell for executing this command, and this command is getting the input from echo, and it is storing it into this variable, but it is a variable in the subshell, and as soon as this command is finished, the subshell is also terminated, and the variables that are stored in this subshell are erased as well, are removed, and this is the variable reply in the current shell, and it is unset. So this does not work, this kind of pipe. If we use a named pipe instead, for example, echo ABC, and then redirect it to pipe 1, and then ampersand, so that it is still running in the background. And now we can read from pipe 1. Okay, it is done. Let's see what is in the variable reply. In the variable reply, we have this this value that was sent from echo. So the difference between this case is this command is being executed in the current shell. So it is saving the value in this variable, which is in the current shell. This variable is in the current shell, and so we can use it later. Now we can remove a pipe as we remove files. So with the command remove, which is used for the files, we can remove this pipe as well. It is like a file, but it is a special type of file. Now let's see another example with a named pipe. Let's create another named pipe again. Make FIFO pipe 1, and now I'm writing a while loop, which is an infinite loop. Actually, while true will never end. Do read line from pipe 1 echo used line, and then done. But actually, I should have used an ampersand. So let me cancel it with Ctrl+C and append an ampersand so that it runs in the background. So it is still running in the background, and if this command read is trying to read something from pipe 1. Now let me send something to this pipe. For example, echo hi, and send it to pipe 1. And now we get this message, you said hi, which is coming from this echo here. And let's say echo hello, send it to pipe 1. And it is printing you said hello, because it is still running. It is an infinite loop here, and it runs indefinitely. And this command is trying to read something from pipe 1. Always it is trying to read something, and as soon as it gets a line from pipe 1, then the next command continues, echo, and it is printing the line that it is reading. Echo. The quick brown fox jumped over the lazy dog and send it to pipe 1. And we always get this message you said, and then the line that we are sending to pipe 1. Now to stop the command that is running in background, we can use this FG for ground. So the command that is running in the background now comes into the foreground, and I press Ctrl+C to cancel it. Okay. And let's also remove the pipe. And this was about the named pipes. Now let's see quickly the questions from quiz number 5, which is the last quiz. So there are about 12 questions. Let's finish them quickly because we also have to write some programs. So the first question, what will display this command? On set A, and then we are setting these values to the A as an array, and then echo this and this and this one. So this is an array assignment. On the index 50, we are assigning the value 5. On the index 100, we are assigning the value 10. Now, what do you think is the output of this one? Echo. This is displaying all the values of the array. The values are this one, 5 and 10. These are the keys. These are called the keys of the array, and these are the values. So with this at sign as an index, so usually this would be either 50 or 100 to get either this value or this value. But if the index is this at sign or it is a star, then we get all the values. So this one will return 5 and 10. 5 and 10. And what is this? What will return this? So the value of the array in the index or in the key 100. What is it? It is 10. It is 10. So this will print 5 and 10, and then this will print a 10. And with this hash, we get the length of an array. So we learned these things about the array in the last lesson. So this is the length of the array, and the length of the array is 2 because it has 2 values. And this is the length of the item in this position or in this index. And the item in this index is 10, and its length is 2. It has 2 characters. So it will be 5, 10, and then 10, and then the length of the array is 2, and then 2. So 5, 10, 5, 10, 10, 2, 2. This should be the correct answer. Let's check it. Okay, it's correct. Let me make this full screen. And also, we can test it. It is easy to test with copy paste or by writing this command. So actually, it is printing 5, 10, 10 to 2, 2. Let's go to the next question. Which of these commands does not print 6? Foo is 10, and then echo this one. All of them, foo is 10, and then this plus plus foo. Will this print 6?
Yes, I think.
Yes. This one, will this print 6?
Echo. Yes.
Yeah. And this is it going to print 6? I think it is going to print because this is an assignment. So
Yes,
it is, yeah. So we are assigning to this one the value of foo plus 1, which is 6. And then I think it is, yeah, maybe this, I'm not sure. So, so let's check them. I think I have some small connection problems. Okay. Let's try. So this prints 6 for sure. Let's try this one. This also should print 6. Yes. And let's try this one. I think it should print 6. But I'm not sure. Yes, it does. And I think this one is not going to print 6.
yes.
This one is not. Why?
Because the variable foo is not I don't know how to say it in the English.
Okay, it is because it is incremented after the value of the variable is used. So it is using the value of the variable and it is incrementing it afterwards, after using the value of the variable. It is the same thing in C++ as well. So this is incrementing the value of the variable first, and then it is using the value of the variable. So it is going to get 6. This echo is going to get 6 as an argument. But in this case, it is getting the value of the variable first, and then it is incrementing it. It is incrementing it later. The same thing in the C language, but you don't learn C. Maybe it is the same thing in Java. I don't know if Java has this one. I don't remember. Anyway, so this is the choice that should be selected because this does not print 6. And this one is incrementing foo. So this should print 6 again. But let's check it to be sure. Yes, it does. Let's check. Next. If the variable foo has the value bar, which of these commands prints bar with capital letters? This one, this one, this one, this one, or this one. What do you think? Okay, you have to remember this because it is something that it is not logical. So you either you remember it or not. So this one makes lowercase the first letter of the value. This one makes lowercase all the letters. This one is completely wrong because the variable foo with uppercase letters is not defined, so it is not going to print anything at all. This one will make uppercase all the letters of the variable foo, and this one will make uppercase only the first letter, which is already uppercase. But this one will make uppercase all the letters of the value. So we can try it. Foo. And then with this one, it makes lowercase the first letter. And this one makes lowercase all the letters of the value. If there were other uppercase letters, then they would have been converted to lowercase. This one makes uppercase only the first letter, but it is already uppercase. And this one makes uppercase all the letters. So this one is going to print this bar, all uppercase. So, okay, this is the correct choice. What will display this command? Echo A, echo B, echo C, sort R. This sort R is sort in reverse. So usually sort will sort them. So this echo A is displaying one line that contains A. This echo C displays one line that contains C. So it should display CBA, but actually this is not quite correct because C is in a single line, B is in a single line, and A is in a single line. So we can test it like this. So without sort, it is displaying first A and then C and then B. With sort, it displays A, B, C because it is sorting these lines. But with the option -R, it is sorting them in reverse order from the bigger to the smaller letter. If foo has this value, which of these commands prints file.text? So to print file.text, we have to remove this .zip at the end. And I think with this percentage, we are removing from the end. We are removing something from the end of the value. With this hash, we remove something from the beginning. And this one, double percentage, is greedy. It is in matching this pattern. So I think the correct answer should be this one. So this is removing dot and then any other characters at the end, which will remove this .zip. So let's actually test it. And then let's try the wrong ones first. So it does not remove this one, but it is removing this one from the beginning. Let's try this one. This does not give a correct result either. So it is similar to this one, but it is removing as much as possible. So it is removing all this one because it is greedy in matching this pattern. And this one, this does not remove anything at all. And this one is removing the last .zip. So this should be the correct choice. Now, which of these commands does not print OK? A takes this value, not OK, and then echo. This is assigning the the value OK to A if it is empty, but A is not empty. So this is going to print not OK, I think. So let's try. So not OK. If A was empty, then it would get this value, but it is not empty, or if it was unassigned. So this one. I think this is going to print OK or not. Let's check it. It says which one does not print OK. So this is the one does not print OK. All the others print OK. All the others print OK. So this is going to print OK because with this plus, it is getting this value if the variable is not empty. So the variable is not empty, so it is going to get this value OK. So all these will print OK, but the first one is not going to print OK. So this is printing OK. And this one, if the variable is empty, it is going to give this error message. But the variable is not empty. It has the value OK, so it is going to print OK. And here, if the variable is empty, then it is going to print OK. And actually, the variable A is empty. So it is going to print OK. And this is similar to this one, but it also assigns the value OK to the variable A. In this case, it just prints OK, but the variable A is still empty. But in this case, it assigns the value OK to the variable A if it is empty, and then prints it. So this will again print OK. So only the first one does not print OK. What will display this command? So we are defining an array here. It has two values, and the keys are 50 and 100, and the values are 5 and 10. And now this is actually printing all the keys of the variable with this exclamation point in front of the name of the array, and with this @ sign as an index. We are actually getting a list of all the keys of the arrays, and the keys of the array are 50 and 100. So it is going to print this one, 50 and 100, I think, or maybe 150, but I think this one it is going to print this one. So let's check it. Yes, it is printing the keys or the indices of the array. What will display this command? On set A, so it is empty, and then A100 gets the value 10. So this is an array that has only one value, and it is in the key 100 or in the index 100. And then this is printing all the values of the array. It has only one value, it is 10. And this is printing the value in the key 100 or in the index 100, which is 10 again. So 10, 10. And this is printing the length of the array. The length of the array is 1 because it has only one value. And so 10, 10, 1. And this is printing the length of the value in this key or in this index, which is 10, and the length of 10 is 2. It has 2 characters. So it is and this is 10 because it prints all the values, and then this is 10, and then 1, and then 2. So 10, 10, 1, 2. This should be the correct answer. And let us check it. So this is correct. What will display this command? Foo gets this value, string, and then echo. What is this? It gives the length of the array. So the length of the variable, because it is a variable in this case. So it is giving the length of the variable. So the length of the variable are how many characters are in this string. And let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it should be this one. Because this does not make sense. This does not exist. 4 is too small. It should be 19. And let us check it. Yes, it has 19 characters. And what will display this command? We have an array here with these two values. Now, what is this? This is all the values of the array. The values of the array are 5 and 10. So this should be the correct answer. Let's check it. Yes. So the values of the array are these, and these are the keys. If the variable image has this value, which of these commands prints this one? So lowercase. This is going to replace something in the beginning. So it is going to replace the first one with this lowercase version. And this is going to replace everywhere. So I think this should be the correct answer, because it is going to replace this one with this one, but because there is a double slash here, it is going to replace it everywhere, not just the first match, but all the matches, this one as well. This one is going to replace only the first match, because it has this single slash in the value of the variable. And this one is going to replace at the end. So it is going to replace only this one. And let's check all these options. And then this one. So it is replacing only at the beginning. So the first match. And then this should be the correct answer. It is replacing all the matches. Yes. And then let's check that these are wrong. Okay, this is replacing only the first match. And this is replacing only the match at the end. So it is matching this pattern, but at the end of the string. So this should be the correct answer. And we have this string again in this variable foo. Now, what is this? What is going to print this echo command? This foo is this string, but we start getting a substring at the 5th position. I think starting from 0, 0, and then 1, 2, 3, 4, 5. This is the 5th position. And then this is telling it that we should get only 6 characters. Starting from the 5th position, we get 6 characters. So it is going to print this one. Let's check this. Yes. And we are done with the last quiz. It was a short one. Okay, let's close this, and then now we will write a couple of programs if we have time. So let's make a couple of programs. We want to make a script that gets as argument the URL of a web page and returns all the URLs inside that page. And then a script that gets as argument the URL of a web page and returns a list of the 100 most frequently used words inside it. We have done these two examples before, but we will also do this this program, a script that collects web pages from the internet, starting from a root page, extracts the words in each page, and creates a list of words. It is related actually to these two because they are used as a helper in this script. So let's start with this one first, a script that gets as arguments the URL of a web page and returns all the URLs inside that page. So first of all, let's say that we are going to use this one as the URL, linuxcommand.org, http linuxcommand.org. So URL http linuxcommand.org echo URL. Now we can use the command wget to get the page from this URL to get the content of this HTML page, and with the option minus capital O, we show where to save it. For example, file.html, and then it will be downloaded and it will be saved into this file. But if we use this minus instead of the file name, then the output will be sent to the standard output, not to a file, but to a standard output. We can also write it like this. So we get this HTML page on the standard output, which is the screen. And let's also use this option, I think Q for silent, so that we don't get these progress messages and so on. So we are getting this HTML page. Let's do it with less. start with HTML and then head and then title and so on, body. Now, what do we want to do? We want to extract all the links in this page, these URL pages from this page. And the links are in this A tag, anchor tag. So from all this page, we want to extract these anchor tags. And we can use the command. Grep to do it. Let me put this option here, and let's use the command grep to extract anchor tags, and this extended, and then it starts with an A, and then a space. For example, we want to match this one, and then I'm saying everything different from a closing tag. So this is going to match everything different from this closing bracket. So this makes it different. So and this star means anything, or we can also use a plus here. And because we are using extended regular expressions, we don't need to escape this plus with like this. So let's see what does it do. So we are getting all the lines that contain these links, and we can actually use the option I for case insensitive, so that we can also get uppercase letters. So sometimes HTML tags can be lowercase, sometimes they can be uppercase. This A can be lowercase sometimes and sometimes uppercase. So we can use this option I, so that it can match also the uppercase tags, if there are some uppercase tags. And something else that we can do, we can use this option O of command grep, so that it displays only the part that is matching, not the other parts. So it is going to display only this red part that is matching with the option O, because we are not interested in this one. We don't need them. We just need this part that contains the link, the URL here. So we get a list of all these A tags, but actually we are not interested in the tag itself. We are interested in the link inside this attribute href. So we can use another grep here to match this href, and then it starts with this double quote, and it ends with a double quote, and in the middle can be anything different from a double quote. So anything this class, anything different from double quote. So it is starting with a double quote, and then anything different from a double quote, and then a double quote at the end. But these double quotes sometimes are optional. So even if in some HTML pages, maybe they don't place the double quote, they just write the URL here, and it is acceptable. So we can make them optional with this question mark after this double quote. So, okay, it is matching this one. Okay, but let's use this because we want to match actually the part inside the double quotes. And let's also add this option O. Yes. But we see that most of them are URLs, but some of them are not correct URLs. For example, this is a mail to address, so it is the address of a mailing it is a mailing address. So we can escape them with another grep, and this V is reverse matching. So it is displaying only the lines that do not match. So we are matching all the lines that contain mail to, but with this V, we display only the lines that do not match. So actually, we are escaping this one. It is not being shown. It is not being displayed. And now we want to remove this from the beginning of each line and this double quote from the end of the line. So let's do it with a sed, and then substitute href equal, and then substitute it with nothing. So we are deleting this one. It is matching this one, and it is substituting it with nothing here, empty. And also let's substitute this double quote with nothing. So we are deleting the double quote at the beginning and at the end. And but we also have to use this G global, because it is matching only the first one. It is substituting it with empty, and the last one is not replaced. But this G global matches substitutes all the matches. Okay, now we don't have this double quote at the end, and so we get a link, a list of all the links inside this page. Now we can place this into a script. And let's call it get URL. So I copied it and now I pasted it here. And we can make it a little bit better. We can make it more readable. This slash continues the command. This slash at the end of the line continues the command into the next line. So just making it more readable. And also this URL is actually the first argument of the script, should be the first argument of the script. So URL is $1, which is the first argument of the script. and we can check that it is not empty, because if it is not empty, then this if it is empty, this wget will fail if the first argument is empty. So we can say if there 0 URL, which means if it is empty, then echo usage. This is the name of the script, and then we need an HTML page. And we send this message to the standard error and then exit with an error code. Otherwise, the rest of the script will continue. Let's make it executable. And let's try it. Get URL. And then we already have the URL into this variable. And it is going to list all the URLs into this HTML page. And let us test it without an argument. It is going to print the usage, the name of the script, and then an HTML page. So this is the first script. The second script is getting all the words into the given page. So we have this URL. It is the address of a HTML page. We are going to retrieve, or we are going to get this HTML page, and then we will try to extract all the words inside this page. So again, we can use wget, or let us change the URL. Let's use another URL in this case. HTTPS Wikipedia Linux echo URL and wget let's also add this quiet here. So we are getting an HTML page, this HTML page. And now we are going to send the output of this wget command to other commands, and we'll try to extract all the words. So first of all, we are going to translate with the command tr all the new lines. So this is going to replace a new line with an empty space, and the result of this is that all the content of the script will be like a big line. So there will not be several. It will have only one line, but it will be a big line. And we are doing this because sometimes the tags are broken. So we have half of the tag in one line, and then half of the tag continues into the following line. And if we join all the lines, then we can process them more easily, because we want to delete all the HTML tags from the content of this file. So the change is not visible, but if we try it with less, yes, but actually it is one line. All of this is just one line. And now let's try to delete all the tags. into this file. You can try with the command sed. Substitute. We are going to substitute something with nothing, and we want to substitute or to delete the tags. So tag starts with this, and it ends with closing angular bracket, and in between it can contain anything different from this angular bracket. Let's use this star. And we actually want to replace it with an empty space, and we use this G so that all the matches are replaced. And let's also pipe it to less. So we see that some words start to appear, and the tags have been deleted from the content of the file. Okay. But we need to make some to clean some other things. For example, there are those so there are things like this into the content of the HTML files. Sometimes there can be things like this, and we want to delete these as well. So we can delete them with another sed command. Substitute and replace it with an empty space and replace everywhere. And it starts with this at sign, and it ends with a semicolon, and in between there is anything different from a semicolon. And again, we can pass it to less to see the result. Okay, this is not a big change. It does not show much change. But now we can use the command tr or translate to convert to a new line everything that is not a letter. So with this option, -c it means complement, which means everything different from. So these are all the letters of the alphabet, and this complement means everything different from them. So translate everything different from them to a new line. Or is this one? And also we want to keep also this single quote. So we are escaping the single quote with this, so that it is itself. And let's see what is the result of this. And we get one word for line and then everything else, everything that does not contain letters of the alphabet has been replaced with an empty with a new line. But we see that there are several new lines. So let's add this this S for I think it is for squashing them together. So if there are several of them, then only one will be kept. So there is only one end of line here. If there are several end of lines, all of them are removed and only one is kept. So we see that now we are getting some words. Okay. But let's also convert everything to lowercase, and we can use another tr so that everything that is in this set of letters will be replaced by the corresponding letters into the second set. So we are making everything lowercase, making sure that everything is lowercase. And now we can sort this, because we actually want to get 100 letters that are more frequently used into this page. Not all the letters in this page, not all the words in this page, but the words that are used more frequently. And so we can sort them. And we see that some words are repeated. For example, adoption. And with the sort and the option C, or we can pass it to the command unique, which is going to keep only one version. If a word is repeated multiple times, or if a line is repeated multiple times, it is going to keep only one. But with the option -C, it is also going to count how many repetitions were. So we see that this after is repeated 19 times. And this alien, for example, is repeated 20 times. So for each line, we have only one word and how many times it appears in this page. And now we want to sort this by the first column, which is a number, and we want to sort it in reverse order so that we get the most frequent words at the top of the list. So we can sort using as key the first column up to the first column. So we are just using the first column, and then we are making a numeric sort and then a reverse, so that the most frequent appear on the top. And then we can use the second column as a second key for sorting. And let's see what we get by this. So this is the most frequent word, which is repeated 610 times. This is the second most frequent word, and so on. And we get the rest of the words down in the list. And actually, we don't want all of them, but we want the 100 words that are most frequent in this page. So let's. This is easy. We can also do it with head. For example, head 100, and we will get only the first 100 words that are most repeated. But it is also another option is this one, said 100, and then quit. So at the line 100, it is going to quit. Okay. But this one is more easy to understand. Head and 100, or just minus 100. It's the same thing. So now let's put this into a script without the command less. In bash. And actually, we can copy something from the other script here. So again, we want to check that the argument is not empty. And we can reformat this big command so that it is easier to read. And let's make this executable. It needs an argument URL, and it is going to output the words that are most frequently used in this stage.